So this is lesson 4, interpreting and using function notation. So the first part we're going to do is on observing a drone. Here is a graph that represents function f, which gives the height of a drone in meters, t seconds after it leaves the ground. So we are going to decide which function value is greater. So I'm going to look at f of 0 and f of 4. So our function, so the input is 0. 0 is t, so that's our time. So I'm going to go on my graph, I'm going to look at 0 seconds and see that my height is basically at 0. Okay, then I'm going to go to f of 4, so t equals 4. So I'm gonna write this down right here. T equals 0. T equals 4. So we don't know our actual number for the height, but we can look at it right here, and we can look at the 4 and find on our graph, we can see that 4 is greater than 0 with the output that we're looking at. So f of 4 is greater than f of 0. Okay, then we're going to look, I'm going to switch colors here. We're going to do t equals, not 0, 2, and t equals 5. So at t equals 2, we have this height in meters. Then we can look at t equals 5, and we can see that we have this amount. What we can see, are these, is one of them bigger? Sorry, I'm trying to see how I want to word this. Okay, so is one of these bigger? No, they're the same. So f of t, or f of 2, sorry, equals f of 5. They have the same height. Okay, let's do the next one. We have t equals 3, and we have t equals 7. So at t equals 3, I'm going to go up and see that I have this height. And then at t equals 7, I have this height, which should be 0. So which one's bigger, 3 or 7? 3. So my function at 3 seconds is greater than my function at 7 seconds. So now we have letters. We have f of t, or f of t plus 1. So I'm going to erase this over here. You don't have to if you did this. But I'm just going to pick a number for t and see what it might give me. So if I say t equals, I'm going to do this in a different color again. I'm doing black. So t equals, let's say 1. So is f of t, so f of 1, let's redo that. F of 1, is it f of 2? Why did I put 2 for the other one? Okay, so it would be 1 plus 1. So it would be f of 1 plus 1, right? So we get f of 2. So f of 1, is that greater than f of 2? No. So it's going to be less than. But what if I have t equals 6? So I would have f of 6 and f of 7. So f of 6 plus 1 is f of 6, so right here, greater than f of 7, so right here. Yes. So is it going to be one specific direction every single time? Is f of t always going to be greater than f of t plus 1? No. What about the other way? Is f of t plus 1 always going to be greater than f of t? No, because we can see that it's going to flip-flop. So it would depend on the value of t. Okay? I'm going to flip to the next page. Yours is on the bottom of this page. This is a different page for teacher presentation materials so that I have a little bit more space and perhaps sometimes different diagrams to show you guys. So let's go to the next page. For me, we have smartphones. The function P gives the number of people in millions who own a smartphone T years after 2000. What does each equation tell us about smartphone ownership? So we have P of 17 equals 2,320. What does 17 represent? Does that represent my time, or does that represent my number of people? 17 is T, so T equals 17. What does 2,320 represent? People. So, what year would we be talking about for 17? 2017. So in 2017, how many people in millions? So how many people does this number right here mean? So this is going to be, we have thousands here, but that's supposed to be in millions. So what we're going to do is we're going to say 3, 2, 0. So we have thousands. We need to make this number right here be our millions. So we need to add 1, 2, 3. We need to add that many zeros. We could also say, let me redo that. I'm going to put this in parentheses, or 2.32 billion people own a smartphone. Okay, what does P of negative 10 equals 0 tell me? So what is negative 10? It's going to be time again. So T equals negative 10. So what does 0 mean? People. So what year is negative 10? 1990. In 1990, how many people? 0 people own a smartphone. So last hour I went ahead and looked this up for reference. Smartphones were invented in 1992. So, not any smartphones. Yes. Not the same as what we experienced today. I don't think they had touch screens back then. There's probably more like the BlackBerry kind of like thing, you know? Yeah. All right. Next page. All right, use function notation to represent each statement. We have, in 2010, the number of people who owned a smartphone was 296,600,000. So what would my equation look like here? So first thing I want to do is say, in 2010, what would my T be for in 2010? 10. So T equals 10. The number of people that own the smartphone was this. What is this number in billions. So if I take away 6 decimal places, that's what we're going to do. So we're going to go all the way over to here. So we want our people, our total number, to equal 296.6. So what would my equation look like in function notation? What did it look like on the last page?
So it was P parentheses the time.
So capital P, parentheses, what?
The
10, parentheses, equals, what does it equal?
2,966.
Okay, 296.6. Okay, so on the next one, we have in 2015. What is my T here? T would be 15. What would my people be for 1.86 billion people? We need to be in millions, not billions. So we need to move the decimal place over 3 places. So we are going to have 1,860 people in billions. 1,860 million people. So what's my equation going to be here? Yeah, that's exactly correct. So P parenthesis 15 parenthesis equals 1,860. All right, my is curious about the value of T in P of T equals 1,000. What would the value of T tell my about the situation? What do you think it would tell my? So the 1,000 tells me the number of people.
Oh, the time.
So T would tell me the time. So T would tell my when that's going to be billion people had a smartphone. Okay, is for a possible value of T here. So if I look up at, well, let's just look on this page because we had some on the other page too. When P was 10, how much did we have? 296.6 million. So could we have had 1 billion people having a smartphone in 2004 if we didn't even have 1 billion in 2010? No. So it is not possible because less than that had a smartphone, or less than, instead of saying that, say less than 1 billion. Had a smartphone in 2010. Oops. All right, now we're going to graph this. So we're going to take our, I'm going to put down here, we're going to have a coordinate of T for our X value and P of T for our Y value. Okay, so my coordinate, my XY coordinate is going to be T, P of T. So I'm going to go back and I'm going to get my -10 was 0. Then we're going to get, what else? What other number did we have back here? We had 17. So we will have 10, which was up here, was 296.6. Then we're also going to have 15, which was 1,860. Then we will have 17, which was 2,320. So you should have all 4 of these points on your graph. We are going to start with the negative 10, 0. That's going to be our easiest one to put on there because it is on the x-axis right there. So I did this one. I'm going to go do number 10, the second one, sorry. We're going to go to 10 on the x-axis. Then we're going to go up to about 300 because 296 is very close to 300. So we're going to have a point. It should be really close to the center of this, and I'm going to try to get it there, but we will see how that goes. That looks better. Okay, so I have this one, and I'm going to make that one a little bit bigger now that I have a good spot for it. Now we're going to go to 15 on the x-axis, and then we're going to go up to 1,860. So 15, go up. We're going to be real close to 1,900 on this one. So it's going to be about the halfway point between this line right here, which is 1,800, and 2,000. So we're going to go about right there, slightly below the halfway point would be ideal. So let's make that a little bigger and go down, make it centered. And lastly, we're going to do 17 to 2,320. So that one's going to be closer to the 1,400, but still kind of close to the center, or the 2,400. Sorry, I think I said 14. All right, then we're going to connect our dots. So we're going to go, so this was 1990. We know that smartphones were not invented until 1992. So our line is going to stay on the 0 until 1992, which is going to be this -8. And then we're going to slowly bring it up to here. And it's okay if it's not fully straight. Then we're going to see that we have almost like exponential growth, which we will talk about later in this class. And it's probably evened out some now because almost everybody has a smartphone. So let's see here. I believe the next part on your paper is the Are You Ready for More, which tells you to go back and see if you can figure out when 4 is a possible value. Or no, not 4. I can't. No. So what would be the possible value of t for my situation? So when did the population of people that had smartphones reach 1 billion? So right in here, about how many years was that? So probably around somewhere in there. Your graphs may be a little different than mine. We were saying last hour between 12 and 13 years, so around 2012 to 2013. Do your graphs look like that? Roughly around that time frame is when we reached 1 billion people having a smartphone? Okay, again, getting some head nods. Yes, that does sound correct. So around t equals 12 to 13, or 2012 to 2013. All right, we're going to go to the next page. This is our last activity for today. So the function W gives the temperature in degrees Fahrenheit of a pot of water on a stove t minutes after the stove is turned on. It says take turns with your partner, but instead we're just going to walk through this together. So at W of 0 equals 72, what does that mean? So that is going to mean that at 0 minutes, the temperature is 72. So at 0 minutes, the temp is at 72 degrees. So I'm going to go ahead and graph this down here because I know it says to do this. So we're going to go to 0 and go up to just below this line. We're going to be real close because this line is going to be 75. We're just not going to be quite on that line. So for B, we have W of 5 is greater than W of 2. So what that's going to mean is that 5 minutes, or 5 minutes, has a greater temperature than 2 minutes. Makes sense, right? If you have a pot of water on the stove, it's going to get warmer every minute, right? Okay. There's not a way for me to graph that. Whenever we go and graph and connect the other points, we're going to make sure that my 5 is going to be greater than my 2. So for right now, we're going to leave that as it is. Then on C, we have W of 10 equals 212. So at 10 minutes, the temp, I can't write today, the temp is at 212. Okay, so at 10 minutes, we need to go up to right at around the halfway point between 200 and 225, because the halfway point between those two numbers is 212.5. All right, so D, we have W of 12 equals W of 10. So the temperature is going to be the same. Will be the same at 10 and 12 minutes. So I can go over here, and this is 12.5. So right before that line, we're going to have the same temperature. W of 15, so the water temperature at 15 minutes is greater than the water temperature at 30 minutes. So the temp at 15 minutes will be greater than the temp at 30 minutes. And lastly, we have W, or the water, at 0 minutes will be less than the water at 30 minutes. And this makes sense because if you put a pot of water on the stove, when you initially put it on there, it's going to be lower than the temperature whenever you take it off if you actually turn the burner on, right? So let's connect these points that we have. So we're going to connect this. It should be kind of steady growth. What's going to happen now? Does anybody know what the temperature is for boiling water in Fahrenheit? Anybody remember? So the temperature at which water boils is 212 degrees in Fahrenheit. Okay, so it's probably going to stay about the same and then start to go down. I don't believe at the top it tells you that it's only boiling for a little bit, but we do know that at 30 minutes, the temperature of the water is less than at 15 minutes. So the water is probably going to boil for a little bit and then go down. So was our temperature at 0 minutes less than our temperature at 30 minutes for this graph? So at 0, right here, the temperature was less than right here. Yes. Was the temperature at 15 minutes greater than the temperature at 30 minutes? Yes. What about at 5 minutes? Was the temperature at 5 minutes greater than the temperature at 2 minutes? Yes, because we were going up. All right, make sure that you do your practice problems on Canvas, and I will see you guys in class.